It's really hard to make this video because I just walked the dogs and now I want to go eat on a patio somewhere. But I want to knock this out first, or at least get it started. So this is going to be a kind of lecture video on the last component you need for the final, not the final, the midterm exam. I think which chapter is chapter 5. We haven't covered chapter 5 yet, but I want to review a little bit of earlier chapters too. So I want you to see. Hold on, let me do this. I've got a figure here somewhere. Let me pull it up. Not that one. This one. So abstraction levels. So this whole past few weeks, you've kind of got the access, which is supposed to give you a little bit of practice of implementing this stuff. But at the same time, you should be side by side researching this process kind of, and what the process is. First, learning what data is, and then learning different ways of having data in databases, the different kinds of databases like hierarchical, network, object-oriented, big data, all this stuff. But you really want to focus on the entity relationship model, the relational databases. That's where that's still the big majority. If there's a question on that, what's the most common kind? It's relational database. You want to look at that structure, and then within that structure, you want to learn like the process. If you're familiar with the software development lifecycle, it's sort of a similar process where first you do discovery of what's the requirements, I guess you would call it, like how's everything set up, what do the people need that I'm making this database for, and what are the rules. That's where business rules come from. That's this top layer here. So there's this abstraction level. Keep this always in mind. First, you're going to start with like the people who actually are going to be the end users of the database you're going to create, the people who actually work in the environment. When I say work, again, from the business rules video that I made, and I haven't finished grading that yet. I want to prioritize getting these lectures, and then I'll catch up in grading. But it's not necessarily a business. It could be any kind of organization or structure. It could be your comic book collection, and you're the end user, right? But it's probably easiest to think of it as sort of loosely a business-oriented thing. So these external models, these are what the person would describe to you as their view of what they're doing, and it might depend on their specialized roles. I don't emphasize this as much, but in reviewing the reading, I noticed that they talked about it in a little bit more detail, and I feel like it's not like you don't need to know this, but it's not as emphasized, that aspect of it. And what I'm saying is that each different person, depending on the job they do, are going to have a different perspective on the way everything's set up. And I'm trying to get to the part in this that I want to show it. Here's what I'll do. I'll pause. All right, so the dog's growling. He's about to bark. So this is the example that's used in the book. I'm going to pause. Every damn person's got to walk his dog through my cul-de-sac because it's a pretty day, and I can't complain because that's what I just did. I walked over probably about 2 miles in my neighborhood. Anyway, so the thing that they're showing is this is like one organization, and there's people involved in registration. They have one view of how everything's done, and this might be more like the administration and stuff. And this is the side like the scheduling. I could see this as more of like what a student or a professor or a department offering the classes would see. So in this case, you're showing that and you've got the business rules in here. So the thing about business rules, I'm going to try to lightly talk about that too, is that the business rules come from these external views, and this is what you would come back to the person with and say, hey, once you explain how this works, you would ask them, is this what you see as from your view of the data? And then you would go from here. So for the registration activity, I guess you would see that a student can enroll in one or more classes. He will have to enroll in one, and if a student does enroll, it would be one student. You can think of that as an enrollment. So a class can have many enrollments. So this is the showing a bunch of students taking a class, and then a course. It says generates here. You could say a class is a section of a course. So the way to think about this is you're taking a CITC 1303. Your sections because there's two of you together. Frankly, there's two sections, there's two classes here, and one Brightspace and one teacher, WOO and WO1. W00 actually, and W01. Those are two sections. Those would be two different classes here. So class, people use them interchangeably, course and class all the time. But one good distinction to make between the two is the class is the blueprint for the course. It's what you read in the course catalog. This is the thing you get credit for when you take it. A class is an instance of that. So you take that cookie cutter and you make the cookie, which is the class. So that's going to have certain particular students in it, and it's going to happen in a certain time. And if you look at this view of a class over here, it's in a certain room, taught by a certain professor. And of course, there's the course here. But so this course, you'll have a section taught in a certain room, Monday, Wednesday, Friday, 9 a.m., whatever, by a certain professor. And this is showing you that you can have a room can have many classes in it. It's not, you don't make a room just for one class, Monday, Wednesday, Friday, right? And of course, you can have more than one. The two that you see right now on the mini side here for you guys would be W001 and W000. That's two classes of this course. Then the professor can teach many classes. So I'm teaching 1303, you guys, two sections of it, and then I'm teaching a section of CITC 2340 and a section of 1301 this semester. So, and that's the view like I would have of it. Maybe some students or my dean would have this view, and this might be more of like the administration side. And then you can have maybe a whole combined view of this whole thing. This would be the ER diagram. So this is the conceptual model, they call it. This is the external model. To me, they're sort of the same thing. They're the logical model that you generate from learning all the business rules. So I'm going to pause here. So this is chapter 2-4. This is where business rules are introduced. And again, a business rule, it's just the name for it. Let's see what they say. A description of a policy, procedure, or principle within an organization. For example, a pilot cannot be on duty for more than 10 hours during a 24-hour period. Or a professor may teach up to 4 classes during the semester. Now, when you get to the ER diagrams, these usually get somewhat simplified. So it'd be more like, for that first thing, it would be pilot can be on duty for, you wouldn't really see that one in the ER diagram so much. But the second thing, professor may teach up to 4 classes during a semester. That's the one we just saw where a professor teaches more than one class, but each class is taught by one professor. So this is what they look like. They tend to look like something like this. A customer may generate many invoices. An invoice is generated by only one customer. That's a one-to-many relationship. When you put it in the model, but this is the rule that relationship comes from. You can see this is the 2 directions for this particular one. A training session cannot be scheduled for fewer than 10 employees or for more than 30 employees. Again, that might be harder to see in the ER diagram, but it's still a business rule. So you take all these business rules and then you model what you can as far as the database goes. How this would be handled where you have like fewer than 10 employees, 30 employees, there's ways to make those constraints in your database, but you wouldn't normally model it at the conceptual level. Maybe you have notes on the side somewhere. I can't think of a way to actually model this. With a Chin diagram, I guess you could put 10 to 30 somewhere in there, but the point is the business rules are how you describe how the data and the entities and the relationships work, like the rules. Well, that's what they're called, right? But the policies it's just a description of how everything works. And then you take those and then of course you have to discover them somehow. So maybe interviewing people. I don't know exactly what they say here. Maybe you can read the manuals, the employee manual, like what he has to agree to when he's hired. And then you talk to all the managers and stuff and they'll tell you what all the rules are. And then you maybe interview employees, like, how do you see the data? What are the kind of questions you need from the data? Do you need to know? Do you need a way to see how many courses a professor signed up to teach this semester or whatever? Questions like that, and then you translate those into data model components. Is what they say here. But this is a good, like, you would just have these little sentences, basically. You would have a list of these, as many as you can. And then the next step, I don't know if they have it here. Yeah, we don't look at that right now. Pause. Okay, we take all those rules and stuff, write out the business rules, and then you would create an ER diagram. And what I'm trying to show you here on this thing, this is the different levels. So this is where you actually talk to the end users, get their different views of it, put all that together into something like a list. First of all, a list of business rules, then take those business rules and translate them into a diagram, an ER diagram, whether Chen or Crow or UML or whatever it is. And this is all logical level. So what this means where you got these lines here is that at this level, you could take that ER diagram and go to Access or go to SQL Server or go to Oracle or go to MySQL or Postgres or all these different relational database management systems, all these different softwares. Go to them, and you can take that, and it would be fairly easy, regardless of what the software is, to translate that model, that diagram you've got, that plan into each one. So this is where you say it's logically independent, because you can take the software doesn't really matter and the hardware doesn't really matter. Now, once you've made a decision about how you're going to which thing you're going to implement those on, let's say you pick Microsoft SQL Server. That's the internal model. So you translate that diagram to what you need, the tables you need, and how the foreign keys relate, and what data types you pick for the different fields in your table. And then like more advanced stuff that you don't know yet, but like stuff like triggers and procedure and functions and stuff about how to display the data. That's more at this level, the internal model. It's software dependent. It depends what you can do at that level and how you do it exactly. Depends on how Microsoft SQL Server does data types. Maybe they have different names for the same kind of data type. So they might have something called a, what's the word I'm trying to think of? I want to say short string, but they'll have like maybe a varchar, for example. And then another database management system calls that thing where basically a varchar would be a variant length of just characters. Like you could make up like an address, for example, would be a different amount of characters each time, because you don't know how many characters are in the street name or names of people. Those will be variant amounts of characters, and you're not doing any math with them or anything, so it's just characters. Varchar might be called something else at this level. If you were doing Access or Oracle or something, they might have slightly different names, but they'll all have ways of doing what you need to do at this level. It's just, it depends on the software, what you actually choose. This also, you can put the thing I keep coming back to about junction tables, also called associative entities, bridge tables. Those things don't necessarily have to be in the conceptual model. You could make a step, one final refinement in your conceptual model is that you anticipate that when you get to this part right here, that you will have to have a bridge table. So you put it in the model. You could leave it out too if you know how to convert a many-to-many relationship into two one-to-manys with a bridge table here. So this is what I was going on about with the whole bridge table thing. But as you see, there's a process. You like gather what the rules are from the different views and, figure out how everything works, make a plan for it, draw a model of it, a map kind of, take that map and decide which kind of software you're going to use and translate that map to what you would have to have inside the database management system that you pick. And then underneath that, this would all depend on the hardware, like whether you have virtual machines that spin up or whatever. There's all kinds of different like esoteric stuff about how the software and the hardware work at this level, but you usually don't. If you're a DBA, you might have to be concerned about how backups, where they're stored and that kind of thing. You have to know a little bit if you're managing a database about how a table's stored, whether it's spread out over one table, spread out over several files, or in one file, where it's located on the disk, which directory directory location it's at, which folder it's in. Sometimes you have to know those things, but that's all physical level, and that depends on both the hardware and the software. Whether it's stored in the cloud or on a hard disk locally or across several different, so that you have backups automatically. Whether you're doing a RAID system where you check to make sure with checksums to make sure the data was saved correctly. That's all physical model, but you can see how you go from the most abstract to the most concrete through this process. And again, gather an idea of how the data interacts and the entities involved in relationships, draw up a map of it, translate that into the model inside the software, and then maybe if you're managing the database, you need to know more about how things are actually saved. So that's kind of a review of what you should know so far. So from business rules to implement to database management system. And I keep again, I'll make a distinction. A database is a structured collection of data. A database management system is usually software that you use to manage one or more databases. There's a difference there. A lot of people will use database and database management system interchangeably. I know I've done it in videos because I caught myself looking back. I said database when I really meant database management system. Like you would say something like SQL Server database, right? But you mean database management. You mean the software, the database management system. You could argue also like file cabinets and folders are a database management system for your hierarchical database. But so I'm going to put this aside and get to this, finally to the slides, the stuff we haven't covered yet. So I'm going to start covering this. I might take a pause and eat, but you won't know about that unless I tell you, which is what I'm doing right now. But anyway, so advanced data modeling. There's a few, we've learned a little bit about ER diagrams so far. This will give you a little bit more detail, fancier stuff you can do. Specifically this will be on the midterm. I want you to know this is the main reason this page right here introduces the concepts about entity supertypes and subtypes. There are some questions on that, and I want you to see how to interact with that stuff. So pay attention to that. Mostly you should know from previous videos and also from the access stuff, like the more basic ER diagram stuff, the one-to-many relationships and all that. This just builds on that a little bit. And there's also a thing about indices or indexes that you need to know how to work with on the midterm. All right, so I don't know if I want to read this slide to you instead of just showing you maybe a diagram, but the idea is like, say you have a generic type of thing and then it has subtypes. So for example, you might have an employee and one employee is a mechanic and another employee is at the front desk or something. So that they would share things in common because they're both employees, but then they would have things different from each other. Because this is kind of like if you're used to object-oriented programming, this is like a class and subclass. It's kind of like a hierarchical model that's built into the ER diagram too. But the main thing to learn here is how what the different meanings of the different diagram symbols and lines and things are. So here's an example. This is a so I call it specialization hierarchy here. You have an entity called an employee, and that employee has 3 specializations or subtypes. This is the super type. Super means above, literally, in Latin. Same thing, hyper means above. Sub means under. So this is the thing. This is the type that you start with. That they all 3 of these things have in common with this. And then these are specializations of that thing. Okay, I forget where I was at because I paused. So this is showing a hierarchy where you have, they talk about inheritance. So each one of these things down here will have all these things. There'll be a hire date. There will be a type of employee, and that's the discriminator, by the way. Whatever the value of this is tells you what value it has down here, and I'll talk about that more in a second. But in addition to all these things that all 3 of these things have, again, all 3 of these things have all these attributes down here under in the employee box, including the employee, the primary key. As you can see, they all have the primary key, which is a foreign key as well from the employee table. But they'll also have special things that the other ones don't have. So the pilot will have a license and a ratings and whatever med type is. And then you have a title for your mechanic. So talking about the symbology here a little bit, you'll have a couple different things here. You'll have a D or an O inside the circle, and then you'll have 1 or 2 lines right here where it says partial complete constraint. So this is a partial. This one's partial because it has 1 line. And what this means is, it means that any particular employee in this organization could be just an employee. They could be maybe administrators or something. Who knows what else they could be. But the point is that all the just generic employees don't need any other special attributes. They can all be stored in the database, in the employee database, regardless of what their actual job is. But in the case of a pilot or a mechanic or an accountant, they have to have special fields added to just these right here in order to, because you have to know these things about these people. So partial completeness means that you can have employees that are just generic employees. They don't have any of this stuff down here. Or you're going to have employees who are pilots or mechanics or accountants. So the 4 kinds of employees you can have in this particular picture are generic employee or just employee, pilot, mechanic, and accountant. Now the D means is disjoint. Disjoint means that everything below here, you can only be one of the 3. You can't be in a combination. They're not overlapping as the other option. So you can have employees, pilots, mechanics, and accountants, but you can't have some combination of those. You can't have an accountant mechanic, for example. And they all think of this as one box around the whole thing, as one entity with like little subparts inside of it, and they all have this relationship. They can have a zero or more dependents. So again, you'll need to be able to do this on the midterm. This is a basic ER diagram with added stuff to it. The enhanced part is this whole subtypes thing, but this part, you don't forget this part at the same time. So this is crow's foot. This whole thing's a crow's foot model of ER diagram, entity relationship diagram, and you're saying you have an entity called an employee. This will later be a table of some sort in the database, and how you do these at the implementation level will vary sometimes, but they might also be individual tables. You'll also have a table called dependent, probably. Regardless of whether you do or not, though, you have these two main entities, and then you have these sub entities of this entity. And you know it's entities because it says at the top in a bar, a little box here has a singular, all caps, noun that describes what it is. Then you have the relationship between this big entity with its subparts to this entity over here. And what we're saying is that any particular employee could have many dependents. Maybe has 3 kids. Maybe has a spouse and 3 kids. Each one of those entities, instances of an entity, could be a dependent. So maybe he's not unmarried and has no kids, then that's why you have optional here. That's the 0. So 0 or more dependents, and each dependent will be dependent on exactly one employee. And this dependent will not even exist if there's no employee. That's where you see the mandatory. It's not optional. You don't have dependents in this company unless you have an employee. So that's just reviewing basic crow's foot diagram meaning right there. But don't forget what I just told you here. This is the part you need to learn that's new, this subtype stuff. Again, you have a circle, it'll have a D or an O in it, and then you'll have 1 or 2 lines. So let's see if we can find an example where you have the other the variations on this. So here's one where you have variations. So in this particular slide, you have the same kind of thing going on, except in this case, the way the subtypes relate to the supertype is a little different. So what we're saying is that this is a total, it's called total completeness or something like that. You look up the term, but the important thing is that you know how to interpret these 2 lines. The 2 lines means that you don't have generic persons. You don't have generic people. This, if you were talking about object-oriented terms, for you guys who know that, this is just for you guys who don't worry if you don't know what I'm talking about. But if you know object-oriented programming, this would be an abstract class. So you never implement this class, you never instantiate it. It's just meant to be inherited from. Now, you would implement it in the database. You probably have a person database, maybe not a table. Maybe you just have the employee and the student. That's going to vary how you implement it. But the point is that all employees will have a P name, a PF name, a P is imp, and a P is Stu. They will have all these attributes. All employees will, and all students will also have all these attributes. The is indicates to me that this is a Boolean. So a Boolean value, you need to know that term too, just in IT in general. It comes from a guy named Charles Boole, who created a whole algebra based on true-false, and how true-false relationships interact. So, if you have 2 things that are true, and you say this is true and this is true, then the whole thing's true. If you have this is true or this is true, or true or false, then the whole thing's true. That whole logical interaction of true, false values. A data type that's a Boolean is a value that's either true or false. So these attributes right here where it says is imp or is stu, these are going to be true or false. 0 or 1 if you want. There's different ways you can implement it at the internal level, but at the logical level, it's true or false. Now, it has an O here, which means overlapping. That means you could have people. Now, you can't have just generic people. There's no just person because of the 2 bars. But there can be people who are just employees, people who are just students, and people who are both. They're going to be one, the other, or both. If they're neither, you just don't have them in the database, right? If the value of the person right here is 0 and 0, you just won't have them in the database. So one of these is going to be true, at least. Maybe both. If both are true, then you have a student who's an employee student. And then you got a student who on the side tutors or something, and he gets paid. Or you have an employee who teaches, and he's not taking any classes. Or you have somebody, who's just a student. The employee will have an office. The student's not at that level. So that's just showing you that you can have subtype relationships that other subtypes don't have. You're not seeing any of the relationships that all the people have here. You don't see anything for that. You just see this relationship. So again, the 2 lines means that you have to be either a student or employee. You can't just be a generic person. The O means you can be one, the other, or both. If it was D here, then you could only be a student or you could only be an employee. You couldn't be both at the same time, but the O means you can. If this doesn't make sense, listen to this a couple of times and then study it on your own and see if it makes sense. The 2 moving parts you got here are this completeness thing, whether you're completely subtypes or you can have generics or not. That's the line, 1 line or 2 lines. And then the D or the O, whether these things can overlap and you can have more than one person. One individual being both things in both camps, or just has to pick one. That's disjoint. Disjoint means not overlapping. I guess there's no other way to say it. All right. And the idea of which one you are in here depends on these values. If only one of these is true, then you're only that one. If both are true, then you're both. So that's why it has P is imp and P is stu here. That's how you decide which one of these 2 you fall into. And then inside of that, there's further subtypes. So an employee could be an administrator or a professor. And a professor can administrate, apparently, because this is O. And you could have an employee who's neither one of these. So you could maybe have janitorial work or admissions or financial aid or whatever. And what we're saying here is that all these employees have a hire date. They have is an admin or not. Well, what we're saying here with the single line is that both of these could be false. Up here with the 2 lines, we're saying that at least one of these has to be true. Because of the O, you could have 2 trues. But because of the 2 lines, one of them has to be true. Here, you could have 2 falses and just have a generic employee. You can't have a generic person because 2 lines. But you can have a generic employee because 1 line. And the reason why is, again, only administrators or professors need they need titles and ranks and stuff. For rank at Pellissippi, you've got instructor 9 month. That's me. I'm not actually a professor yet. I'm going up for promotion next semester in the fall, so wish me luck. But then at which time I will become an assistant professor, I think is the title, then associate, and then if I get a PhD, I could go up for a full professor. Those are the ranks. We have these ranks. It is hierarchical here at Pellissippi. And then an administrator could be like president, vice president, dean of student affairs, whatever, who knows. And then you could have professors who do, because of the O, you can have somebody who's both of these things. So because of the single line, you can have employees, again, like financial aid, who are neither of these. And the reason why is the reason why you have this model at all, you have the subtypes, is because financial aid and facilities and all those, they don't need any other special in this particular business rules, right? This is not saying, this is not the rule everywhere you have these things. This is just saying in this particular model, what it's telling me is that in this organization, we don't have to know further special things about financial aid, or I'm just assuming these exist. They might not even exist, or facilities, or whatever, marketing. We don't need anything besides these four. And really, we only need two. We need the hire date, and we need three. We need the primary key, which is inherited from the person. We need that. We need the hire date, and we need the office number. These two things just exist to tell us whether or not they're one of these. Again, they're Booleans, true or false. If both are true, then that person will have both of these. They'll have a rank and a title. If one's true, then maybe they just have the rank or the title. Over here, it's disjoint. It's the same thing. What we're saying is a student, but what we're saying is that you do not have generic students. Why do you not have generic students? Because there are two bars. This is total completion, or whatever the term. I don't actually know the term. You guys probably should look it up. I don't think it's on the test though. But you do need to know what this map means, and that's what I'm trying to tell you. So disjoint means that you will have either a graduate student or undergraduate student. Disjoint means you can't have a graduate student who's also undergrad, or undergrad who's also grad. That just doesn't exist. You might have graduate students who are taking undergraduate classes, but their classification is still graduate. If they are an undergrad, their classification is not graduate. If they're a graduate, then their classification is not also undergraduate. That's what the D means. And then the double lines means there's no such thing as a generic student. All students are either graduate students or undergraduate students. That's all. That's the two lines. I hope that makes sense. If it doesn't, I said everything you need to know from this, I think. I can't say it in any other more special way, I don't think. So you'll want to maybe replay what I just said to make sure you understand it for the test, and look at some other examples, and of course do the reading. Right, you go ahead a couple of slides. There's this table. It is called completeness constraint. That's the line, one line or two lines horizontal. This is like the different variations that you can have. You have 4 different types of relationships of those things, depending on whether it's overlapping or disjoint. You can read all this, see if it makes sense to you. It kind of makes sense to me because I know what it's talking about. I feel like the examples are more instructive than memorizing all this stuff, though. Compare this to what I just went over in the last slide, where you actually see the diagram and see if all this stuff makes sense. But supertype has optional subtypes. This is partial, right? So optional subtypes means that what this means is that if you're a person, no, let's go back to a couple of slides before that. Let's do the employee. The employee can be either a professor or administrator. That's the optional subtypes. What it's saying is that you can have an employee who's not, the optional part means they don't have to have a subtype. They might, but they don't have to have one. When it's total and overlapping, then you're saying that they have to have a subtype. They must have a subtype. That's total, but it could be one subtype, the other, or both. So in the discriminators, these are the Booleans I was talking about, true or false. Like in this, the way they do it, and all the diagrams we just saw were true, false value. Is student, is not student, or whatever. Is admin, is prof. Those are the discriminators. All right. Let's just see if that makes sense to you. All right. I didn't expect, this is actually a short bank of slides, but it has this section on primary keys. And I think it's valuable enough to talk about, because whenever you talk about primary keys, that's always valuable because they're very important in relational databases. So let's talk about it a little bit. So entity integrity, there's 2 kinds of integrity you talk about a lot in relational databases. There's entity integrity and what is it? Relational integrity? Referential integrity. I had a brain. I blanked on it for a second. Referential integrity is the one you hear about the most. You hear about that all the time, especially when you're designing a database. In that transition from the conceptual logical model to I swear to God, somebody's home. All right, so I got just interrupted. I just realized I haven't done a video lecture on my favorite chapter, probably. I don't know, I like normalization a lot too, which is after the midterm. But I'm going to do chapter 4. So I'm gonna do that after this. But so I'm gonna put them up in reverse order. So I'm gonna do this, finish this one, and then put the other one up. So you'll have a couple of videos to watch. You've learned a lot about Chapter 4 already, incidentally, when we talked about the access labs and stuff, but this will be like a good review of what you've learned and maybe introduction to some concepts that we kind of skipped over. But which also makes this video not the final word. I need to make videos in between the semesters that are not tied to individual events in the particular class. So I can just put those. But anyway, primary key. So let's talk about primary key. So entity integrity. If you have primary keys, you have entity integrity. So entity integrity means that every record is different from every other record. You don't have any duplicate records or duplicate rows in a table. If you have duplicate rows in a table, then you don't have entity integrity. So basically, having a primary key guarantees that you have entity integrity because primary keys are unique. So it's a single attribute or a combination of attributes. So it's a single column or a combination of columns. It could be 1, 2, 3. It could be the whole row combined. And if that's unique, that could be a primary key. But that's not usually how we do it. We try to either pick 1 or 2 columns or attributes or fields to make a primary key. But it uniquely identifies each entity instance. So I'm glad to see that because I keep using that word, but I didn't know if anybody else did. An instance of an entity is a record or a row in a table. But yeah, so it uniquely identifies each row. It uniquely identifies each record, however you want to say it, in a table. So it guarantees entity integrity, and it works with foreign keys implementer. So you use a primary key. This is if there's a question about do you ever use redundancy of data redundancy on purpose in a relational database, the answer is yes. You use redundancy in the form of primary and foreign keys. The foreign keys will be a copy of a primary key, and that's how you show the relationship. That's the part where you use redundancy constructively on purpose. All right, so the rest of this slide bank is about best practices, I guess, for primary key. So let's look at it in a little bit of different terminology. So natural key is just some kind of attribute value of something that uniquely identifies it naturally. So you could say if everybody had his own name in the universe and there was not more than one John Smith, then that would be a natural key because it's actual data outside of the database purposes that you use to make the primary key. If you could combine John Smith and his date of birth and his address and some other things on a record all together to make one big primary key, and that uniquely identifies that record from and all the records are uniquely identified that way, then that would be a natural primary key because you're using actual data about the person to uniquely identify the person. In this case, it's a person. It could be an object or something in a different table, but if you use the things, here's one big example: Social Security. It could be considered maybe a surrogate key in the actual Social Security Administration because there's nothing about you that means your Social Security number should be what it is. I mean, I think it is actually based on like certain numbers or for certain regions and stuff, but there's nothing. It's not like it's a combination of your age and your name and stuff or whatever that makes a Social Security number. It's kind of an arbitrary number. So in that way, it's surrogate. But the fact that you have it already when you come into, say, another database system could turn it into a natural thing because it's something about you that already exists that you could use to uniquely identify you. But there are problems with that because then there's security problems, right? If you are hired somewhere, they need to know your Social Security number and stuff for tax purposes. So they have to store it somewhere, but they might not want to use it as the primary key. I'll tell you what, at UT, when I was first a student there as an undergrad, your student ID number was your Social Security number. And if you lost your ID, they'd stick a 1 on the end and a 2 and a 3, depending on times you lost. I never lost mine, but pat myself on the back. But that could be because it was on your ID card. So if you lost your ID card, so people would know your Social Security number. So that wasn't a good choice, even though it's a natural key in that instance because it already existed about the person and you're just using it to uniquely identify that person. But it wasn't a good choice because of security reasons. All right, so that's what a natural key is. Just some data value about the thing, or a combination of different things that already exist about the thing that you use for a primary key. And most of the time, you're not going to use that in a database, and I will show what you use instead. Okay, so I don't know what non-intelligent means here. I guess I'm not sure what that means. I need to look that up, but it's not that important. If it's probably, I probably know it as a different name. Non-intelligent, intelligere, or whatever. That means to be able to tell apart is the root meaning of intelligent. It means to be able to distinguish something from something else. Maybe it has something to do with that. It's intelligible, right? You can tell what the writing is, because you can distinguish the letters from each other or whatever. That's what the root meaning of it is that. I want to say in between letters originally is what the word is. Legis means letter, also law in Latin, and inter means between. So the R would become like a fade in with the L. So to be able to read between, I don't know, look it up. No change over time. So a primary key should never change, ideally. That could really mess things up. Preferably a single attribute. Yeah, it's better when it's a single attribute because you can avoid some problems down the line that we'll learn about. Second normal form in particular, and we'll talk about what that means. But the fewer fields you have involved in the primary key, the less trouble you're going to have. Preferably numeric, I guess. I mean, I could see how it'd be a combination of letters and numbers maybe would be okay, but I'm not sure why they say that. Security compliant, though, that's why you don't use social security number, ideally, because that has security implications. Okay, identifiers, composite entities, each frac is a... Okay, you do need to know about this on the midterm too, and that's why I wanted to make sure I did talk about these things. So identifiers of weak entities. If an entity has as part of its primary key the primary key of another table, then it's a weak entity. So an example would be employee and dependent. So if the employee primary key is like 1, 2, 3, 4, and that's their ID, and the dependent of that employee is 1, 2, 3, 4, 1 for the first child, 1, 2, 3, 4, 2 for the second dependent, and so on. If it's a combination of the 1, 2, 3, 4 for the employee primary key, and then another field 1, 2, 3, 4, 5, 6 for which dependent they are, that makes that entity dependent a weak entity, and the relationship between that weak entity and the entity, the relationship between a dependent and an employee in my example is a strong relationship. If part of the primary key is involved in the primary key of the other thing, then there's a strong relationship between them. So a weak entity will almost always, it will be the case where a weak entity has a strong relationship. It's called a weak entity because it would just not even exist if you didn't have the entity that it's attached to, the strong relationship with. So a dependent would not exist in your database unless you had the employee. That's why it's called a weak entity. And it's a strong relationship because they have that primary key in common. The primary key of one is part of the primary key of the other. That's a strong relationship. Make sure you write this down and memorize it so you know it for the exam. A weak relationship is one where there's no primary key sharing. There's no parts of primary keys in the primary keys of the other. That's a weak relationship, and it's a strong entity. It could exist. The patient could exist even if the doctor didn't exist. In a way, I guess you could think of it that way. It depends on how you model it. You could have a doctor-patient database where the primary key of the doctor is in the part of the primary key of the patient, and in that case it would be a weak, and you'd say, well, there would be no patient if there were no doctor. Depends on how you model it. Those are decisions you make. All right, so there's another case where you have a weak entity, and this is the many-to-many. I've talked about this many times, and if anybody doesn't understand this at this point, it's because you haven't been paying attention, because I like to talk about this. So this is where you have the many-to-many relationship, and you create a new entity in between them. So in the database management system, you'll have a new table. This will be a weak entity. that has as part of its primary key the primary keys of two tables actually, and there's a strong relationship between them. So in this case, you have a student can take many classes and a class can have many students in it. This is a many-to-many relationship. Just ignore this enroll for now. Ignore the enroll, stretch this claw all the way over here to class, and take this claw and stretch it all the way over to student. Get rid of the one things. They're gone now. That's the original relationship you had. A student can take 0 or more classes. A class can have 0 or more students in it. Probably not. I probably have to have at least one, right? But so that 0, the optional might change, but it doesn't here. You were saying that a class, what this means is that a class may have never been offered, right? This is a student. The student may have never been, he's enrolled at the university, but he hasn't taken any classes yet. So that's why you have the optional there. But in order to model that, implement that in the database management system, you need you need 2 one-to-many. You can't do many-to-many. You can do that in a network database, but you can't do that in a relational database. You have to take that many-to-many relationship between the 2 tables and create a third table and make 2 one-to-manys, and we call that enrollment. And you can see how class code is part of the primary key. You take the class code; it's a foreign key. So that's the FK1, but it's also part of the primary key because what you have is a composite primary key. You take 2 fields, class code and student number together, combine those together, and that will make one primary key for the enrollment. Because again, a primary key can be 1 or more fields put together. In this case, you have 2 fields put together. You have the class code and the student number of the enrollment put together. That will uniquely identify a row. What does it uniquely identify? It uniquely identifies that this student took this class, whatever the class is. So let's say student number 101 took class number 1224. Or let's make it more relatable. Let's say you listening, you're student number 1. That's your primary key. You're taking 1301 W00 2021 or whatever. That's the primary key of the class. You put that together and that shows that you're taking that class. And then like at the end of the term, you'll get a grade for that class. So that's a third. This is not part of the primary key at all. It's not a foreign key. It's not a primary key. It's just more data that you have, and you get a grade at the end of the class. You might get A, B, C, whatever. That again is another instance. This is called an associative entity in data in ERD terms and entity relationship diagram terms. This is called a bridge table in DBMS terms, or a junction table. Again, one many-to-many relationship is turned into 2 one-to-many relationships. You'll see this over and over again. This is a weak entity. It has a strong relationship with each table. Enroll, because it has studnum here, has a strong relationship with student. And because it has class code here, it has a strong relationship with class. Each one of these primary keys is part of the entire primary key of this thing. This thing is a weak entity. I don't usually talk about it being a weak entity a lot because it's a special entity that you use for many relationships, but technically it is a weak entity that has a strong relationship with each of the tables involved. You could make it, I want to say you could create a surrogate key and then just have the foreign keys that are not part of the primary key, and then that would magically become a strong entity with weak relationships, but that doesn't make a lot of sense. So anyway. Surrogate primary key. So a surrogate primary key is a key that you just pull out of your hat. I was gonna say hat. To use specifically for the purpose of entity integrity. Specifically to be a primary key and nothing else. This just exists in that database management system to be a primary key. So it's useful when there's no natural key. Now, here's the thing: some purists will say you should use a natural key when you can, but I kind of lean towards just make a surrogate key for everything because it's cleaner. Anyway, so yeah, it would have to be unique. It has to be a unique value for each record, and it has to be not nullable. It can't be just no value. It has to be a value. So a typical thing you'll do is like start with 1, and then just just add one every time you add a record. So the next record you add will be 2, and the next record you add is 3, and the next record you add is 4. As long as you keep those unique, that's a surrogate key. You can also like randomly generate some letters and numbers or some from some scheme. As long as you don't ever use one, then that could also be a surrogate key. Anything that's not actually just part of the data is a surrogate key. All right. I had an interruption. So when to use surrogate? I would just use them all the time. I don't know what they're saying to do, but I would use them all the time. I don't know what this table is supposed to be showing. I guess it's kind of hard to see what the primary, how you would get entity integrity out of this one. Keep track of events. So a certain date at a certain time. Look, you can't. It looks like there's 2 different things happening at the same time. So like if you were doing natural keys, just combining the date and the time start would not give you entity integrity, would not give you a primary key. If you combine the date, the time end, and the room, then it looks like you're sort of getting towards entity integrity. That might work. Because if you have the room, you can't have 2 events at the same time in the same room, probably. That's probably against the business rules. They would try to avoid doing that, right? So, and you see how the date's different here. So that would probably work. That would be an example of using a composite key that's also a natural key, because it naturally is part of the data. I would prefer, though, add a column and just call it event ID and just start numbering 1, 2, 3, 4, or whatever. That would be a surrogate key if you added a column that just its specific purpose is just to be the primary key. So foreign keys work with primary keys to implement. So you've done this in Access. So this is just like showing. I don't know if this is the first time formally in a lecture video we talked about it, but so you take the primary key of an entity on the one side of a relationship, and then on the many side, in the many table, you take that primary key and put it in a column somewhere, one of the columns of that many side, to show that there's a relationship between the 2 things. So let's look and see if they show an example here. I don't know if they really, this is the ER diagram, so let's look and see what, this is showing 1-to-1 relationships. So this is showing, here the primary key on one side is the employee number, and the foreign key for the department the employee is in. He's only in one department, and the department will only have, this is what, manages. I was going to say, surely you have more than one employee in a department, but this is managing specifically that relationship. So every department has exactly one manager, and every employee, it manages exactly one department. He doesn't manage several, he manages one. And if you have a manager, you don't have 2 managers for your department, you just have one. So one way of showing that relationship in a database where you have 2 tables, a department and an employee, and there will be a field called employee number that you might call this manage. You see how it says FK1 imp num? You could call this manager num. You could change the name. It doesn't have to have the same name, but what it does have to be, it has to be one of these values for the primary key. So manager, let's say employee number 17 is the manager of this department. You would have 17 as the value right here for the foreign key. So you take that 17, that's a primary key over here for one of the records, and put it as a value into one of the fields in the department. So department number 1 has employee number 17 as the manager. And that's just showing that, also this is all showing that a department will have one and only one manager, and a department has to have a manager. You don't have a nobody's managing department. That's what the 2 lines mean. But an employee may or may not manage a department. Like obviously you don't want too many cooks in the kitchen. So that's what the optional means. An employee manages 0 or 1 department. I don't know why I ended right there, but I'm going to end this video right here, and we still need to talk about indices. I thought that was in this chapter. It's not, so I have to find out where it is and talk about it. So I need to talk about indices, and I need to cover chapter 4, and I want to do that now, but then show chapter 4 first. And so is the end of this one.